Welcome to evaluating the Laplace transforms of basic piecewise functions. So recall, if we have some f of t, which is equal to 0 for t less than tau, and which is equal to g of t for t greater than or equal to tau, then f of t can be written as a step function, u of t minus tau times g of t. And also the Laplace transform of f of t is the Laplace transform of u of t minus tau times g of t. And this is the same thing as e to the negative tau times x, multiplying the Laplace transform of g of t plus tau. So we can use this trick to find the Laplace transform of basic piecewise functions. So let's consider the function f of t equals 0 for t less than 5 and 2t plus 3 for t greater than or equal to 5. So then we have the f of t is equal to the step function evaluated at 2t minus 5 times 2t plus 3. Here 2t plus 3 is my g of t. So we have that the Laplace transform of f of t is equal to the Laplace transform of u of t minus 5 times 2t plus 3, or times g of t. And this is equal to e to the negative 5x times the Laplace transform of g of t plus 5. So then it becomes, what is g of t plus 5? Well, g of whatever was equal to 2 times that thing plus 3. So g of t plus 5 should be equal to 2 times, in parentheses, t plus 5, close the parentheses, and then plus 3. So we have that g of t plus 5 is equal to 2t plus 13. So our Laplace transform of f is e to the negative 5s times the Laplace transform of 2t plus 13. At this point, this should be recognizable. I need to give myself a little bit more space to complete it. Continuing forward, this becomes e to the negative 5s times, in brackets, we have 2 times the Laplace transform of t plus 13 times the Laplace transform of 1. Again, using the linearity of the Laplace transform. The Laplace transform of t is just 1 over s squared, so this becomes e to the negative 5s times 2 over s squared. The Laplace transform of 1 is 1 over s, so this becomes plus 13 over s, and then 2 over s squared plus 13 over s should all be in parentheses. So this is essentially our Laplace transform, or we could write it as e to the negative 5s or 2e to the negative 5s, or we want to write that, e to the negative 5s times 2 over s squared plus e to the negative 5s times 13 over s. So this is how we can go about taking the Laplace transform of our piecewise f of t that we had. Let's go ahead and do one more example. Let's find the Laplace transform of f of t equals 0 for t less than pi over 2. And sine of t minus 2 cosine of t for t greater than or equal to pi over 2. So once again, f of t is the step function u of t minus pi over 2 times sine of t minus 2 cosine t. So here our g of t is sine of t minus 2 cosine t. So if we want to take the Laplace transform of f, this is the same thing as taking the Laplace transform of that step function, u of t minus pi over 2, times g of t. And of course, this is equivalent to e to the negative pi over 2 s times the Laplace transform of g of t plus pi over 2. So once again, our g of whatever was sine of that blank minus 2 cosine of that blank. So in place of all those t's, we are now instead going to put in t plus pi over 2. We do not have formulas for the Laplace transform of sine of t plus pi over 2. However, we can use some Trig rules to rewrite these in a format that are recognizable for the Laplace transform. So we will now use the fact that sine of a plus b is equal to sine of a times cosine of b plus cosine of a times sine of b. And cosine of a plus b is equal to cosine of a times cosine of b minus sine of a times sine of b. So we're going to use these facts to rewrite our g of t plus pi over 2. I need to update my screen quickly. So we're going to use these facts to rewrite g of t plus pi over 2. Which we had said was equal to sine, excuse me, sine of t plus pi over 2 minus 2 cosine of t plus pi over 2. So that sine of t plus pi over 2 becomes sine of t times cosine of pi over 2 plus cosine of t times sine of pi over 2. And then we are subtracting 2 times cosine of t cosine of pi over 2 minus sine of t times sine of pi over 2. The 2 is multiplying those last two terms I wrote out. Some things to keep in mind. Cosine of pi over 2, that is 0. So cosine of pi over 2 goes to 0. In both places it appears. Sine of pi over 2 is 1. So sine of pi over 2 goes to 1. And so I need to update my screen once more. So once we've done that, we simply wind up with a g of t plus pi over 2 is cosine of t minus 2 sine of t. So from here, we therefore have that our Laplace transform of f of t is equal to e to the negative pi over 2 times s times the Laplace transform of cosine of t minus 2 sine of t. So we have e to the negative pi over 2 times s. All of that multiplying the Laplace transform of cosine of t minus 2 times the Laplace transform of sine of t. Laplace transform of cosine and Laplace transform of sine are both ones that we are familiar with. So we get e to the negative pi over 2 times s multiplying Laplace transform of cosine of t is s over s squared plus 1. Then we have minus 2 times the Laplace transform of sine of t, which is 1 over s squared plus 1. So we wind up with e to the negative pi over 2s multiplying s over s squared plus 1 minus 2 times 1 over s squared plus 1. So this is how we can go about evaluating the Laplace transform of a basic piecewise function.